which will be f of 1. So this is 8 and this is 1. So this is simply natural log 8. So I found a point. So I need y minus y1 equals the slope times x minus x1, where the y1 is natural log 8 and x1 is 1. Of course, I need to determine the slope at 1, which means I have to find the derivative of, so dy over dx or y prime, whichever notation suits you. It doesn't matter, they mean the same thing. The first function prime 2x, natural log of 5 plus 3x to the fourth, plus x squared times 1 over 5 plus 3x to the fourth times the inner function prime, which is 2x to the third. Don't bother with this, just find dy over dx when x is 1. And let's see what we get. So I get 2, again natural log 8, and let's see what I get here. So the numerator is 12, the denominator is 8 again. So this becomes 2 natural log 8, and I'll simplify by 4 plus 3 halves. So this is what I have to enter here. And from this point on, it's just algebra. So y minus natural log 8 equals 2 natural log 8 plus 3 halves and x minus 1. Is this, let's stop for a moment and see if this is okay so far. Now, I'm hoping for some simplification. It doesn't have to happen, but I'm hoping. So y equals, don't forget this has to go to the other side. I have to distribute here, but I will not. I will just write it as is. But I have to distribute negative 1, so I have negative 2 natural log 8 and minus 3 halves and plus natural log 8. So I can only combine like terms, the negative 2 natural log 8 with positive natural log 8. And that's it. And there is nothing else I can do here. So y equals 2 natural log 8 plus 3 halves x minus natural log 8 minus 3 halves. And this is it.
I had a question.
Yes, please.
For my final answer, like I didn't fully simplify. I just put like in the part where you add ln 8 to the other side, I just put everything in parentheses that wasn't simplified, and then I added minus ln 8. Would that be acceptable, like on like?
You mean minus, when you say minus ln e, what do you mean?
Oh, ln 8. Plus ln 8 at the end.
Yeah, it's okay, but this have to be simplified. So that's why I'm always hoping that my students will work on the problem that we did in class and see that this was fully simplified. M times x plus a number which is mx plus b. So that's why I cannot assign homework before class, because I always assign similar problems. So that's always my hope, that students will study this first, so they can see, you know, pretty much what is expected. It's okay, but it's not fully simplified. But it's okay. It's acceptable. But normally when we solve for y, we have to have what? mx plus b. Good. Very good question. Anything else? Other questions? Anybody? Thank you, Haley. Anybody else? Okay, in that case, we'll go back to chapter 3. And let me just go back and re-explain this. We're trying to finish this chapter in 4 meetings, plus review after the spring break, and have the test afterwards on Wednesday after the spring break. So we have many applications of differentiation. That's why we study differentiation so much. And one of the applications is graphing. We're going to add more. these two derivatives, the first derivative and the second derivative, say a lot, give us a lot of information about the function. For now, we're going to look at the first derivative. What does the first derivative say about a function? It will tell us if the function is increasing or is decreasing. And it will tell us whether the function has a local or relative maximum or a local or relative minimum. So from the first derivative, we find two things about the function. If the function is increasing or decreasing, or if it has a maximum or a minimum. In order to determine max min, increasing, decreasing, we have to look at something called critical number. What is a critical number? Will all functions have critical numbers? No. If they don't have critical numbers, they will never have max or min. If they do have critical numbers, it's no guarantee. There is no guarantee that they have max or min. But there is a guarantee that if they don't have critical numbers, they don't have max min. So I find critical numbers in order to check whether the function has max min. If it has critical numbers, there is a chance. If it doesn't have critical numbers, no chance for max min. But I have to check for any function, I have to check two possible sources. Number one, I find the first derivative and I set it equal to 0. When I solve this equation, if I find critical numbers, then I'll say the function may have max min. But I don't know yet because I have to study. What do I have to study? The sign of the derivative. The derivative is the slope of the tangent line. So the slope is positive, so the function is increasing, gets to a maximum. The slope is negative, so the function is decreasing, and it gets to a minimum. Second source. Find the first derivative, and I look at it and see if it's ever undefined at the point or points where the function exists. If the function doesn't exist, how can at that point, how can you have max min? It cannot. But if the function exists, but its derivative does not at that point, there is a chance that the function has a max min. So I have to remember two sources and I have to check for both. Okay, so this was an example. Forget about this example for now and let's choose other examples to find critical numbers for now. And I'll explain again, because this is a very important concept. Okay, I'm opening the book. And this is page 277. Okay. I'm going to share my screen right now. Chapter 3. Here it is. 277. Stop me always, always, always if something is not clear. The more we clarify in class, the less you have to do at home. The less work you have to do at home. Please. Okay. So, for example, you can choose any problem you want. If you want to choose, please go ahead. But I like to look at something with natural log this time. So like 31. Just to find the critical numbers. So we have 31 on page 277. So we have g of x equals natural log of x squared plus 2x plus 6. We are asked, does this function have critical numbers? I have no clue. Maybe. Can anyone help us understand what steps we need to perform? What do I have to find first?
The first derivative.
Excellent. So g prime of x. Remember, it's natural log of a function. The rule by now, please, I hope you know the rule by now. 1 over the function times the function prime times 2x plus 2. 1 over the function times the inner function prime. 1 over x squared plus 2x plus 6 times the inner function prime, which is 2x plus 2. Do we agree with this step, with the derivative? Okay, perfect. Now, I have to look at two sources. F prime of x equals 0, and f prime of x being undefined when the function is defined. Notice that we did not determine the domain of this function. Well, the domain of this function requires a little bit more work. So remember, anybody remembers we had equations? What do I have to write in order to find the domain of this function? Anybody remembers from the equations from last week? Yes, Isaac, go ahead.
Can't it not, it has to be greater than 0?
Yes, indeed. The quantity that we apply any log to has to be greater than or equal to, greater than 0, not equal to 0. Excellent. Thank you so much. Good. So now, g prime equals 0. That's the first possibility. The second possibility is g prime of x equals undefined. We did not solve this yet. I'll explain in a minute. Good. So, I have a fraction. When is a fraction 0? What is this fraction? It's 2x plus 2 over x squared plus 2x plus 6. When is a fraction 0? We established that months ago. When is a fraction 0? Only when? This is algebra. We should not need to think. When is a fraction 0?
When the numerator is 0?
Thank you very much. So 2x plus 2 equals 0 means x equals negative 1. So we found one critical number. Now, when is a fraction undefined? Again, we established that also a long time ago. When is a fraction undefined? Anyone, please?
When the denominator is 0?
Excellent, very good. Thank you. Was it George?
Yeah.
Thank you. Good. This is quadratic polynomial. I don't want to waste too much time. I'm going to use the calculator right away. I go to apps. I go to 9. Polynomial root finder. It's quadratic, yes. I enter that's not what I meant. I enter the coefficients. And the coefficients are 1, yes. 2. And 6. So I want to see if this denominator can never be 0. And I click on enter. The solutions are imaginary, which means never 0. Never. This never happens. So we do not have any critical numbers coming from g prime being undefined. G prime is always defined, and the function is always defined. So this is the only critical number. We checked both sources. Now, I'm adding a question here. That's the end of the answer, the problem. But I want to add the important question here. Is x equals negative 1 a max min? It doesn't have to be. The function has a critical number. It may be max min, but no, not necessarily. If it has no critical numbers, it will never have max min. But we did find one. So please understand this table, and this is extremely important. I keep saying that all the time. Okay, so g prime is the first after x. values of x. Anything. How come? Anything. This is always greater than 0. It's always positive. Good. And then g of x. So x, values of x, the second row is the first derivative, and the third row is the function itself. And I'm going to plug in -1. Can anyone tell us what to write immediately under -1 in the row for g prime? What should I write in here? And then I'm going to ask you where does this value come from?
Is it just 0?
Exactly, but that's how we found this. How did we find this? G prime of 0. G prime equals 0. That's exactly it. How do I find g of -1? How do I find this value? I have x equals -1. I want to find g of -1. Can anyone tell us how to find g of -1?
Plug in everything.
Absolutely. Thank you so much. Thank you, Shona. Very good. So we go to y equals, clear everything, get out of there, go to y equals, clear everything. Enter this function, which is natural log, in parentheses, x squared plus 2x plus 6. X squared plus 2x plus 6, close. Good. Second and table, and I'm plugging in -1. I want an answer. And the answer is 1.61. Perfect. Good. Now, here's what I want to determine. If the slope of the tangent, in other words, if the sign of the derivative on this side is positive and the sign on the derivative is negative, what type of point will this be? -1 comma 1.6. If the slope here, if g prime is positive and then on this side g prime is negative, what type of point is -1, 1.61?
It's a maximum.
Excellent. What if I determine that the sign here is negative and the sign here is positive? If we're discussing this now. What if I find that the sign here is negative and here is positive? What type of point will -1, 1.61 be?
Minimum.
Minimum. Question now. What if this is negative and this is negative? What type of point is -1, 1.61? In other words, I'm telling you the function is decreasing all the time.
It's neither.
Exactly, nothing. Excellent. What if it's positive on both sides? In other words, I'm telling you the function is increasing all the time. What type of point is this? Anyone?
Same thing as neither.
Nothing. Very good. Now we are in the position to find the sign here and here. One possibility is plug in the second derivative, plug in the first derivative in the calculator and then plug in a number to the left of -1. Any number that you want to plug in, like let's say -10. And plug in any number to the right of -1, let's say like 7. Don't put them in the table. Just plug them in the derivative so we can find the sign. There is a simpler way, but let's do that. So I go back to the graphing calculator and I put in the derivative. And the derivative is, in parentheses please, 2x plus 2 at the top and you divide by, and in parentheses always, x squared plus 2x plus 6. And close. So now, notice that the first derivative is in red. We only care about left and right. Of course it's 0 at -1. We knew that. That's why we want a point or an x value to the left of -1 and 1 to the right of -1. Good. So what is the sign to the left of -1? The sign of the first derivative to the left of -1. Anyone, please?
It's negative.
Excellent. And to the right. Thank you, GS. And to the right.
Positive.
Positive. I'm going to stop sharing. Negative. Positive. So now can anyone, again, clearly identify -1, 1.61? What type of point is this?
It's a minimum.
Perfect. Local minimum. How do I know? The slope of the tangent line here is negative, and the slope of the tangent line here is positive. So it has to be, the only chance, the only possibility is a minimum. Any questions? Any questions? Okay, I want to share my...
Question, actually.
Yes, please. Please, any questions?
Just, if we go back to step 2, why did we use the original equation? Why didn't we use 2x plus 2?
Are you talking about the first derivative?
No, go back one. You remember how we did the two steps at the beginning? So why do we use for that one? Why did we use 2x plus 2 equals 0? And then for the second we used x squared plus 2x plus 6.
Very good. Perfect. A divided by B is 0 only when A is 0, is undefined only when B is 0.